Hello everyone. This is another problem from RMO 2016. This is a very beautiful problem from geometry. So it states that we are given two circles omega 1 and omega 2 which intersect at x and y. Let P be an arbitrary point on omega 1. Suppose that Px, Py meet omega 2 again at points A and B. Prove that the circumcircles of all triangles PAB have the same radius. So what it means is that as P moves along this circle, we need to prove that the circumcircle of every single triangle PAB should be the same. So what we one way to do it is we take 2 points P1 and P2 and show that their circumradius are same. Note that because these 2 points are selected arbitrarily, this means that we can do this for every pair of points and hence the circumcircle of all triangles PAB have the same radius. So we will prove that the circumcircle of P1 A1 B1 and P2 A2 B2 are the same. So I've already drawn the diagram. Uh, so first thing to notice is that angle XP1Y, which is this angle, let me denote by another color. This angle is equal to this angle XP2Y. Let's denote by alpha. This is because XY segment subtend equal angle on any point of the circle. So these two angles are same. And notice that by sine law, we have that like sine law in triangle P1 A1 B1, we have that A1 B1 upon sine alpha equals to twice of radius. So R1 equal to A1 B1 by 2 sine alpha. And similarly, we can write A2 B2 upon 2 sine alpha equal to R2. So we need to prove that R1 equal to R2. So we need to prove that A1 B1 upon 2 sine alpha equal to A2 B2 upon 2 sine alpha. So we need to prove that A1 B1 equal to A2 B2. So this is what we need to prove. So let's do some more angle chasing. So another thing to notice is that this small red angle, which is angle P1 x P2 equal to this small angle, which is equal to P1 y P2 by the same argument. So A2 x A1 equal to B2 y B1, and if we join A1 B1, we get that angle B1 A1 B2, this angle is also red, which means it is same as all other red angles. This is because B1 B2 subtend the red angles. So this is equal. And if we join A2 B2, this is a very rough diagram. So if we join, this is also the red angle. This is because A1 A2 subtend this two red angles. So let's say this is X, this is X, this is X, this is X, X and X. So because see these two angles are equal, like B1 A1 B2 and A1 B1 A2, hence these two lines are parallel. And notice that if a trapezium is cyclic, it means that the trapezium is isosceles. We can easily prove that. So I will not prove it here. So because this trapezium is isosceles, we get that. First we get A1 B2 is parallel to A2 B1, which implies A1 B2 B1 A2 is isosceles trapezium. But notice that A1 B1 and A2 B2 are the diagonals of the isosceles trapezium, which implies that A1 B1 equal to A2 B2 because they are the diagonals of isosceles trapezium of an isosceles trapezium. So hence they have to be of the equal length. So hence we have proved that A1 B1 equal to A2 B2, and this completes our proof. Thanks.